This is activity 4, the cool down for lesson 13. It's called 2 lines. And in this activity, you're given 2 lines, and you're supposed to write 2 possible equations for this system of equations. And then how many solutions does this system of equations have? And to write those equations, you have to make a decision of what length you want each unit to be along the x-axis and the length of each unit to be along the y-axis. And I chose, in this case, to make those lengths equal. So I just drew a circle here, and the radius of the circle is going to be the length along the y-axis and the length along the x-axis. So equal lengths for both of those units. It doesn't have to be, and I'll show you a couple of examples of that in just a moment. So if this is the length, if this is 1 unit along the x-axis, and you have to imagine this is then 2 units, 3 units, 4 units, and 5 units. And the length along the y-axis is 1 unit. So this slope is 1 unit along the y-axis for every 5 units along the x-axis, so it's 1/5. And if this is 1 unit along the y-axis, then you have to imagine this would be 2 units, 3, 4, 5, 6, 7, 8, 9, and 10. So this would be 10 units along the y-axis. So if this is 0, 0, then this point right here is 0, -10. This point right here is 0, 1. So if this is 0, 1, 0, -10, this is -5, 0, and this is right here, -5, -11. So now to write an equation for each line, this slope is 1/5, and the y-intercept is +1, so this is y equals 1/5 x. This is the slope 1/5, and this is the y-intercept of 1. So it's 1/5 x plus 1. And the equation for this line down here is the same slope, 1/5 x, or 1/5. So that's slope times x plus, and this y-intercept is -10. So this is y equals 1/5 x plus -10. So notice that the slope for each line is the same, but the y-intercepts are different. So when you have that situation, then there are no solutions to the system of equations. You have parallel lines, there's no intersection, there's no solution, because the lines, each line has the same slope, but they have different y-intercepts. So no solutions for this system of equations. Now here's an example where the length along the x-axis is different than the length of each unit along the y-axis. So this length is 10 units along the x-axis, so it's 10 minutes in time, but this length along the y-axis is 20 kilometers. So that's a much different length for each unit of kilometer than for each unit of time. So 1 unit of time is going to be about right here, and 1 unit of kilometers actually is going to be kind of buried in there. Here's another example. This is 1 unit in months, so this is 1 month, but this is $50. So it says cost. It doesn't say cost in dollars, but let's assume it's cost in dollars. So 1 month, this is $50. This is $100. This is 1 unit, 1 month. So very different lengths for each unit. So this length along the x-axis is 1 month. This length along the y-axis, $1, would be very tiny. It'd be 1/100th of this length right here. Very small. So this would be good practice for students to label these axes different lengths. So maybe this length right here is 1 unit, and this length right here is 1/2 unit. Or this length right here is 10 units, and this length right here is 1,000 units. So you decide what those units might be. Try to decide what kind of story would fit that situation.